In this video, we're going to take a look at multiplication of matrices. And the first thing I have written is the identity matrix. So whenever you have ones down the diagonal and zeros everywhere else, we're going to call this the identity matrix. And if you multiply a matrice by the identity matrix, you get the matrix that you started with. So it's just like multiplying by 1. We're going to use this in the multiplication and when we find inverses. So I just wanted to put it out there. It's introduced in this section with multiplication. And then I want to take a look at the general form of multiplying. So we have A times B, and I have two 2x2 matrices. Now it's important in multiplication that we look at the dimensions. So we have a 2x2 and a 2x2 matrice. If the inner numbers of the dimensions don't match, we cannot multiply them. So here 2 and 2 match, and then whatever the outside dimensions are, that's going to be the dimensions of our solution matrix. So we have a 2x2, 2x2, so the inners match and the outers give us a 2x2. So when we multiply together a 2x2, we get a 2x2. And we're going to go across the rows and down the columns. So across the rows on the left matrix, down the columns on the right matrix. So when we do this, we're going to have A1 times B1 plus A2 times B3. And all of that goes in row 1, column 1. So we can actually split this up with some dashed lines so we can see what goes where. And then in row 1, column 2, we're going to go across row 1 and down column 2. So we have A1 times B2 plus A2 times B4. And now to get row 2, column 1, we're going to go across row 2. So we're going to start with A3 and down column 1. So we're going to start with B1. So A3 times B1 plus A4 times B3. And then for row 2, column 2, we're going to start with A3 times B2 plus A4 times B4. So now that we've looked at it with some variables, let's take a look at some example problems. So in this first problem, we have a 1x3 and we have a 3x1. So because our inner dimensions match, 3 and 3, we're able to do this multiplication, and then our outside dimensions are 1x1. So this means our solution is going to be a 1x1 matrix. So now to do the multiplication, we're going to go across our row and down our column. So we have 1 times 4 plus 2 times 5 plus 3 times 6. And when we do the math on this, we get 4 plus 10 is 14, plus 18 is 32. So we have a 1x1 solution matrix, and the answer is 32. And the next example I have a 2x3, and I have a 2x3. So here we can see that our inner dimensions don't match, so we cannot perform this multiplication. So there's no work to be done. In the last example, I have a 2x3 and a 3x2. So in this case, the 3's match, so we can do the multiplication, and our solution is going to be a 2x2. So we're going to have, in order to get row 1, column 1 in the answer matrix, we're going to have 5 times negative 2 plus negative 7 times 3 plus 1 times negative 4. And you don't have to put the dashed lines. I'm just trying to make sure that we're clear what numbers are going where while we're working through these first couple. So in the next, we want to get row 2, column 1. So we're going to go across row 2. So we have 3 times negative 2 plus 2 times 3 plus negative 4 times negative 4. And for row 1, column 2, we're going to have 5 times 1 plus negative 7 times 5 plus 1 times negative 2. And row 2, column 2, we start with 3 times 1 plus 2 times 5 plus negative 4 times negative 2. And then when we rewrite it, we add all those up, we get negative 35 in row 1, column 1. We got that by doing negative 10 minus 21 minus 4. And in row 2, column 1, we have negative 6 plus 6, and then plus 16. So we have 16 here. And now we have in row 1, column 2, we have 5 minus 35 is negative 30 and minus 2. So we get negative 32. In row 2, column 2, we have 3 plus 10 plus 8, giving us 21. And that concludes our video on multiplying matrices.